Hey, what's up, people? We are back at it. Round number 2 here. So, first off, we were trying to figure out the final form save system, and we're still doing the whole brainstorming thing and figuring things out by prompting ChatGPT, Claude, etc. to try to get the best save system. So that's where we are still. Okay, so basically we had a series of questions that we had asked Claude. We basically compiled everything into like a final form, and Claude ended up recommending that we use a threaded system. Using SQLite, I think, database. So it recommended that over and I guess ultimately the speed of Pickle versus SQLite is probably not much different, and the security of SQLite with the database is much more safe and secure. At least that's what I'm assuming the case to be. I'm assuming it's safer because like we can't have file corruption. We also can't have we can't have like partial corruption, wherein like a certain write didn't finish because of the way the databases work. I think it's kind of like it either committed or it didn't type thing. There's no like halfway in, halfway out sort of state. So there was this benchmark it created earlier for testing the concern of, so because it recommended Pickle before, didn't it? It says for your specific requirements, 5 to 10 writes is actually quite low. Only writing trusty data, only writing rarely reading, need crash recovery. A database would add overhead because of connection management, overhead transaction. So it initially recommended Pickle, and so it's saying that Pickle approach is faster, or this is what it was saying. I don't know exactly. But there goes the DC, and that was probably long enough for it to actually kill the stream. If I had to guess, I would say it probably killed the stream right there. So let's go and check this out and see if it killed the stream. Okay, but there. Well, apparently we're having stream issues. What's fucking new, right? I don't even care. I'm not worried about it. It is what it is. So, long story short, we had previously it was recommending Pickle, and then it changed its tune and said that we should use a database instead. I guess it was because I was maybe emphasizing speed. I wasn't emphasizing security. Ultimately, they said the Pickle approach is faster because direct file input-output without a database layer. There's no query parsing. There's no transaction management, no connection overhead, simpler serialization, straight memory dump. Need concurrent access if you need to query the data, if write frequency increases significantly. So it says only if it was 100 pulse per second. If you need to index the data, you need to index search the data. We do need to index slash search the data, I would say. Do need to search the data. That is definitely a requirement. Without a shadow of a doubt, that's a requirement. Because we don't, well, we don't want to have to resave the entire file just to write one object into it. You know what I mean? And so then that was like, okay, well then we would just use shelve because shelve allows for that. So that was that was our progression and thought, is that okay, well if we're gonna use pickle because it's faster, then we would really need to use shelve. Then it comes down to like, is pickle actually faster if we're is pickle actually faster if we're using a database and writing only one attribute at a time? You know what I mean? So I wrote my concerns here. So I'd like to see benchmark. Concern is that pickle is going to dump the entire amount of saved data each write, or is the system using pickle you're committed then each attribute data point only instead of writing every single data point again and again, even though only one data point changed. So it created this benchmark to test this concern, and it compares full state pickle dumps, individual attribute pickle dumps, SQLite individual updates, and SQLite batch updates. And the benchmark will show us the right performance of each approach: storage, size impact, and then real world performance with mixed single multi-attribute updates. You're concerned about pickle dumping in the entire state is valid. The partial state approach I recommended earlier only pickles individual attributes, making it much more efficient. Which took me to run this benchmark. See, and that's what I don't understand. What was it using to do partial state approach? Like, what mechanism was it using? Because you can't only update parts of a pickle file. You have to update the entire thing, right? As far as I understand it, you're either, unless you use shelve. If you use shelve, then you can basically make it work like JSON or a database where you update one specific data point without pickling the entire thing again. So, would you like me to run this benchmark with different data sizes? So I would like to see this state persistence performance benchmark tested, just to see. But like, I also want to know about. So we really have a series of questions that we want to ask here. So we're just gonna like run through these like this. We'll put like, these are questions that I need to know the answer to, and I know this has really turned into a just a really long process learning session. What was the question here that I had? Lots of questions that I need answered if I really want to know what is best without just like choosing, you know. Special will show us. Okay, stay persistent. What exactly was I gonna? What was I gonna ask? Oh, right. How secure? Let's see. How secure or insecure is pickle shelve compared to DB like SQLite, etc. Concerning file corruption etc. What else? What other questions? What is this? How did I do this? How did I open that up? I don't know how I did that. These are all things that we wanted to know, and it's just kind of all over the place because we're considering two different options, and we're weighing the pros and cons of each, and it's stated because there's different forms of them. Like there's a regular pickle, and then there's shelve, and I really want to see this benchmark though, so let's go up here. We're gonna copy this, and we're actually gonna run this. Okay, so we're gonna use this little benchmark. Hopefully, can I just select all? Nope. Okay. What? Does it not let me copy? Like, am I? What is this? What is this, man? Operator error, right? Let's try this again. Now, is it Control C? There we go. Holy shit. I think I actually was able to copy that, guys. Okay, so we're going to go over to test reminders. Let's bring this down here. Now we have we're going to paste that in. We need to go all the way back up here to the top, and we're going to just go through this entire script, and we're going to see what we got going on here. Because, yeah, it's complicated. What is this? With open save file path R plus, this is when we're learning about the difference between R plus and W plus, gotcha, and A plus, R plus, W plus, A plus, and, well, we may end up using that knowledge. We might not apply that knowledge based on if we choose to use database instead here, but, alright, so this is our benchmark that Claude created this all by himself. I did not contribute to this. So we have import pickle, we're importing SQLite 3, we're importing time. I have no experience with SQLite, just as a disclaimer here. Import OS from pathlib, import path. Okay, importing JSON, we're also using JSON, I don't know why exactly. And we're importing types, because for whatever reason, people really like type hinting. People love it. Anyway, so we have the class full state pickle. Well, let's see, what does this do? It well, we have a comment here. It says dumps entire state, each write. Okay, so dumping is saving. It saves the entire state. This would be like the entirety of the game's data that would save, I think. Okay, right, yeah, because this is opposed to individual attribute writing. This is like every attribute writing. That seems extra. I can understand batch writing, but writing everything, that is a bit much. I might not like this test. I don't think it necessarily sure this would be useful here. Let's just give it a once over. State pickle. We got right adder. File path. It's path full state pickle. I've never seen path used like this. You say file path equals path. This is opposed to using the other format, would be using os.path, right? Normally you would use os.path. What we use? Yeah, OS path, and then abs path, and join, OS path join. So why would we use pathlib path versus OS path? We'll open up ChatGPT for this one. This would be like the miscellaneous questions. So we'll say Python pathlib from pathlib import path versus os.path. And it is reasoning for this, and yeah, we didn't put our 16 minutes in, so we got 52 minutes. Alright, gave us our answer. Set correct to, there we go. Let's go up to the top here. This. Okay, so the user's asking about the differences between pathlib and why does it have this? Like, oh, it's telling you its reasoning, like its thought process. It doesn't just give you the answer, it also is giving you this collapsible thought process, it looks like. The user's asking about the difference between pathlib and OSPath in Python. Pathlib, introduced in Python 3.4, provides an object-oriented approach to file paths, making it more modern and flexible than OSPath, which offers string-based functions. I'll explain these differences and give a code how each works. Python OSPath is a traditional string-based module, while Pathlib offers an object-oriented approach to file system paths. Pathlib is more readable, easier to use, and provides better code completion and cross-platform compatibility. It also supports chaining operations and file operations. So it supports chaining operations and file operations. Don't necessarily know what that means. I'm guessing maybe by chaining it means like using join and stuff like that. I don't know. I'll explain how to convert between them too. I'll show some code examples to compare pathlib and OSPath. For pathlib, I'll show some code examples to compare pathlib and OSPath. For pathlib, I'd write p equals path and then the string path and p dot join path to child. So p is the actual path, and then you're doing p join path with the child. For OS path, it's OS path dot join path child. Okay. I mean, is that really that different? Is that really that different? Is it different enough to even like switch from? You know? It's like the same thing, man. I'll also mention that pathlib is more intuitive, offers object orientation, handles file separators automatically, and is easy to read and write. Okay. Both approaches let you work with file system path, but they differ in style and convenience. OSPath provides functions that operate on string paths. OSPath join, OSPath exists. It's been around since early Python versions, works fine, but can lead to less intuitive and more error-prone code since you're juggling strings and functions. Okay, fair enough. Pathlib path introduced Python 3.4 to offer object-oriented way to handle file system paths. Allows you to use operators like slash for joining paths and methods like exists, is file, etc. directly on path objects. Okay, that's cool, I guess. Yeah. Improves readability and maintainability of your code. Okay. Provides seamless cross-platform compatibility and integrates well with other file operations like reading, writing files. So the example comparison here we have using OS path. We would import OS, constructing a path, checking if it exists. Base path equals user. File path equals OS path join. Base path bin and Python. So you're joining Python bin and user, and that is the entire path. And then if os.path.exists file path, which is just a string, it will print path exists. Okay. And then using pathlib path, we have from pathlib import path, constructing a path using the slash operator and checking if it exists. Okay, so instead of using join, we just say file path equals path, and then we pass in user, and then we have, that's actually kind of complicated syntax, right? You have like user, and then you have just a slash, then another string, and then slash, and then another string. Okay. It's basically the same thing, guys. What are we talking about right here? Like, did we really make a new library to do the same exact thing? So we could use slash instead? I don't like how this is written. I like OS path join better. I don't know. Am I wrong here? I don't know. It doesn't seem very intuitive to me. It doesn't seem like an improvement. Generally recommended because it leads to cleaner, more intuitive, and maintainable code. Okay, well, if that's what they recommend, I guess that's what I'll switch over to doing, right? Like, I mean, okay. See, I don't use path, but I liked how this looked. Where is it? Well, let's open up our. Here, so we have path. It just says full state pickle. Now I don't really know what this does. Does this make it a path object? So let's say, does path create a path object? A path object? What does that do exactly? Is that like creating a class instance of the path type? Path does create a path object, which is a subclass of pure path in the pathlib module for file system tasks. For example, p equals path user bin, but it doesn't say p equals path. It just, oh, it does, yeah. Okay. Returns a path object. Expect at least one argument, but on Windows it might accept an empty one. Path.cwd returns the current directory. So path cwd. So let's do this. Let's go up here. We're gonna here, because I need to, you know, if I'm gonna use path, I need to know how to use it, right? Comment this out. We'll go down here and we'll say, let's test it down here. Okay, from path lib import path, and then we say p equals path. Like what? Can we just say? I don't really understand. Let's try to run this, see what happens. Okay. So we have to, like, does it returns it. So if we print this, okay, there we go. We get the run it again. Okay, so this time it returns this. Yeah. See, it returns the current directory. So I mean that's kind of cool. Like that's kind of nice. I like that. Just being able to do cwd to get the current directory. That's cool. But then how do you join? How do we join? So we would do, let's go back up here. Right here, let's copy this. Bring this in. Alright, so then we would say, like, let's say we wanted to go up one directory. Well, how is this that's the parent directory, right? Because this file is actually in Canasta / testing. It's actually in Canasta / Canasta / testing. So why does it not return? I'm confused. I'm a little bit confused here because I would have thought that this would return. This returns deprogramming projects Canasta. But we're actually inside of testing, which is inside of little Canasta. There's big Canasta, little Canasta, and then inside of that there's main and testing parallel to each other, and we're inside of testing, which is where we're executing this from. So I don't know how we get, if we move in the terminal, I don't know why this would have anything to do with where we are in terminal. Let's run this again. Okay. And it's actually still giving us not even the parent directory, but the grandparent directory. So it doesn't have anything to do with... Did it change directory? CD Canasta. Okay, so now we're in little Canasta. And for whatever reason, when we run this file, test reminders, it is actually CDing us out. Man, it's CDing us out. It's changing the directory from little Canasta to big Canasta, and then it's printing that out. That I need to understand this. Figuring out operating system, the actual type of PMID POSIX path. Path object representing the user bin. Let's see. Does path create a path object? Path does create path object, which is a subclass of pure path in the pathlib module for file system tasks. For example, p equals path user bin returns a path object. It expects at least blah blah blah. We already read that. And Python path does, yeah, we already read that. If you call it without any arguments, it generally results in a type error, but apparently it did not in Windows because we didn't pass any args and we didn't get an error. So maybe that's the issue. You're supposed to, what argument does it expect? The argument does return the current directory represented by dots, which is the same as path dot. So, however, on Unix system, with the argument does return the current directory represented by dot. So if we do path dot, let's see what this does. And let's see what is moving this. So if we do CD Canasta to little Canasta, and then we run this, it moves us out. So it's the creation of the path object that does this. It's not actually current working directory. It has nothing to do with this. So if we CD to Canasta, and then we run this. Wonder if this has anything to do with it. Let's CD Canasta again. Now let's do pi test reminders. Can we do testing init? Oh right, because okay, let's try this again. Let's do CD Canasta. No, I'm sorry, CD testing. Okay, now let's run this and see what it does. It still moved us back out. Try this again. cd canasta / testing. And then we do test reminders. All right, let's run it. Okay, so when we run it from the terminal using test reminders, doesn't do what it did before. I don't know why it does that though. That is weird behavior and I don't like that. But we run it with Control F5 using the debugger. It, for whatever reason, oh, it executes this. It's like a package operation. You run using the debugger, it does CD, it CDs to Canasta, and then whatever the AND symbol does to programs Python executable, and then it passes this debugger launcher as well. It's an extra set of arguments, and then the file that you're actually running. So it basically runs it within the context of this debug console. I didn't know that it had this much going on under the hood when you ran it in that manner. So it's actually because it's internally CDing to Big Canasta whenever we run this using Control F5. So that was the problem there. So if we do cd canasta testing and then we run the file like this, bam, it prints out the actual current directory, which is what we would expect it to do. And then if we run it without cwd, we don't get anything returned. Okay, so that's cool. I understand this now. Now, if we wanted to operate using join, now that we understood the issue we were having before, we would instead, okay, we can do dot, and then we can do space / that's / I guess, and then we'll do if we did this, what if we did dot and then, or is this how this works? We would just do, if we did path dot, is that going to return little Canasta? No. Okay. Okay, what if we did a third dot? Okay, so the third dot made it do nothing. The second dot, and then the first dot. Okay, so it's but changing between one dot and two dots doesn't seem to change anything here, as to where normally two dots would mean going up in the directory tree, i.e. if we were currently located in testing, it would bring us up to main, which is the next level up in the directory tree. So there's something going on here that we don't understand. Why does it work this way? I don't know. Alright, so let's try like this. Let's just not pass anything to path, and then let's do it again just to make sure. Alright, and it does indeed print the same exact thing. There is no change. So it's not throwing an error. So then if we do /, then what if we do dot? Is this going to throw an error, or is this going to work as... No? Alright, then let's do... So we would be up to main at this point, and because we're in testing, Well, the current directory would be testing because that's the directory associated with this file. But if we did path and then slash dot dot slash dot dot, that should be 2 levels up. I don't understand why it would print out the same exact thing. So if we did dot dot and then we go to, so this is, the directory should return testing, and then we go up 1 level, so that should return main. Yeah, because testing is part of main. Oh no, it's not. I'm tripping. I'm an idiot. So we have just path would equal testing because it's inside of the testing directory, which is why it returns all this and ends with the testing directory, because that is the directory associated with the file that we're operating from. But if we did dot dot, that should bring us up to Canasta. So if we do slash dot dot and then we go ahead and we run this, it doesn't change anything, but this should be returning Canasta. So then we could do slash and then main, and let's see what happens. Okay, so it's not throwing an error, but how is this directory return a new path pointing to the current? Oh, it doesn't matter. So CWD. Oh, so CWD is modifying it. I understand now. I didn't realize CWD was doing that. I thought CWD was just would print. I mean, you would think CWD would print the current working directory of P, and if P is equal to a certain path, like, I don't understand. So it's just what the method does. The method returns a new path pointing to the current working directory. Now, that's just not what I thought it was going to do. So I was just wrong. That's fine. So this actually is working correctly. So if we were to, like, we can't just make anything up, right? We can't just have this, or is that how it works? Shit, it's messed up here. Once again, let me try to do control. Oh, so it does. This is just a path. It doesn't actually check to see if that path is true. Okay. So if we did this, that gives us just a path object. And if we print P at this point, what does it return? It returns just a dot. Is that right? Yeah, it just returns a dot. And then if we do this, and we let's do Control-Shift-5 to run it with the debugger. It's the same exact thing. Okay. Now if we do could we just do path.cwd? Like, is that the proper way to get the current directory? So there we go. But that's not the actual current directory. Well, yes, it is because of the context. But if we run it like this, There we go. But if we were to remove CWD from it, it would just return dot. But if we have path CWD, it will actually return the working directory, which is testing. Okay, so now this is correct. Okay, so then if we did / dot dot and then /, so this should bring us up from testing to main, and then we can go into, or from testing up to Canasta. So now we should be able to go into main, right? Yes, no? Testing dot dot main. Okay, so let's see if that path actually exists. And how do we do that? Let's see, calling path and argument return the path out represent the current directory. Same path dot. This creates a new instance of the path. It's important to note that the type return differs by OS. On Windows, it's Windows path. On Unix, it's POSIX path. Yes, calling path creates an instance of a path object. Gotcha. Okay. Depending. Yeah. Okay. How to get current directory and then go up a level and enter new directory using path. So it's going to show us how to do this. You would use path CWD for the current directory and then parent to go up. Then you can join the new directory with /. Okay, I see. So we would say from pathlib import path, current directory equals path CWD, parent directory is current dir.parent, and then new directory equals parent dir / new directory name. Gotcha. You might also mention to use file for current file directory, but the user asked specifically for working with path. You can choose this with path CWD to get the current directory, then use parent attribute to move up one level, and finally use the / operator to enter a new directory. Gotcha. From pathlib import path, get the current working directory, current dir path CWD, go up one level to the parent directory using parent dir equals current dir dot parent. Yeah. Okay, this is good. I see now. Not very complicated, just different than what I'm used to using. So let's go back over here. Get rid of this. We can actually use that if path file path exists, because we do want to check that eventually. And here we go. So we have p equals path CWD. So we don't even want to do that actually. We just want to say path CWD. Isn't that how they did it? And you don't have to pass the parentheses. You can just say path CWD. Is that true? Or is that lie? Okay, so it is true. We don't have to calling it on the class. We don't actually have to create an instance. So this isn't. What is the type of P here? I'm just like, man, I don't want to do this, honestly. I didn't want to learn about this. Just straight up. I don't want to spend any more time on this. I wanted to work, you know, on our thing that we're actually working on and not this shit. So it's class pathlib Windows path. So it's the type is class pathlib.windows path. And then if we add the parentheses in and we run this again, it's the same exact thing. So it's one way or it doesn't matter. Okay, and then get rid of this. Now we have file path equals path user bin. Don't want to worry about that. We're gonna do p dot, what is it? Parent. P dot parent, and that is a method or an attribute. It is print p.parent. All right. There we go. So we have the parent would be Canasta, and the actual would be Canasta testing. So that's looking good. Looking good, looking good. All right. And then if we wanted to join, we would do, so we'll say ye.parent, and then how do we join? Say slash because we're up to Canasta, and then we would to main. So now let's call this just Q. Q equals parent slash main. We're gonna print Q. I keep doing this from the debugger, but I can't. I have to do it from. Okay, so that worked. Yeah, we have P, and then we print P parent, which would be Canasta. Then we have Q, which joins parent with main, and we print that, and that's why we get Canasta slash main. Okay, so I understand all this. This works as I would have anticipated it to work, and I'm understanding here. So now if we were to let's make sure it works even further. Let's say main slash, how about this, card.py. All right, now let's print this. Okay, there it is. And then to check if it exists, we do dot exists, print q dot exists, and that's a method. We have to use parentheses, right? Yes. And then if we run it, we get true. Okay, so that means it does actually, or wait, did it create? Does that create the directory? Let's just put X here and see if we still get true. False, right, because there is no X file. There's no X files, baby. And there is no FI. If we just do FI, it's going to return false because there is no such. But if we do card pi, we know that does exist, so we get true. Okay. And then now if we were to use with well, I don't know how we would do this exactly. How you do that with OS, and then you use open. With open, save file as, say, with open, and we'll do Q, which is the card pi path, and we'll open it in R mode. And we'll say as, you know, whatever, QR, whatever, it doesn't matter. We would then I don't know exactly. We'll just print QR. What's QR? It's going to return a file object, right? So let's run this again. There we go. IO text driver name, card, mode, R, encoding. Gotcha. Okay, so it does work. So we got this figured out, boys. So what I should do is I should save this. Oh, should save this. Test segment, and that's enough. That's all I needed to know how to do. That's pretty. I mean, it's cool. It's all right. I like it. Whatever. Sure. Is it that much different than os.path.join and stuff? Not really. Yes. It's a little. It's a, like, I would say 10% improved. Was it worth creating a whole new library? Probably not. I would say no. Just personally, but anyway, I'm just the user, not the developer here. Well, the developer of those that makes those decisions. So let's, thankfully, right? Yes. Okay, so this is just gonna be a fucking reminder that we didn't want to have to remind ourselves about. We deviated. Reminder that we'll give it a title. We always give it a cool title, which would be, this would just be path lib import path example. And this is a reminder that this is how you use pathlib import path. The replacement for os.path. It's a bit simpler and easy to use than the older alternative. Just I didn't feel like, you know, typing with quotes because it just makes me slow. Oh man, so I didn't really want to have to learn this, but there it is. We learned it. That was time that I'll never get back. And a lot of learning going on here, right? We're just learning things that we are pretty sure we need to learn, and it's really that simple. Don't want to learn this shit. You just want to code, whatever. But, you know, can't always get what you want. Okay. So now we can move on to the actual thing we were going to look at. It's like a deviation from a deviation from a deviation until will we ever get back on the track that we started on? I don't know. That's a good question. Maybe one day, right? Maybe one day we'll finish this, making this decision. Jesus Christ. It's kind of pissing me off, actually. Okay, so we got that figured out. What are we doing next? Okay, so we deviated from this file, right? Because we wanted to test this, and we didn't understand how path works, so we had to learn that. So now we're going to go back up here. We're going to re-enable this code, and I got to go relieve myself, and I'll be right back, and then we can actually maybe, just maybe, make some actual progress. And this is sweat. Is this sweat? This is sweat. I don't know what the fuck this is. I'll be right back. I gotta use the potty, man. Okay, here we go. Let's do the damn thing. All right, so we have import pickle, import SQLite 3, import time OS, path, import path, import JSON. Don't know why, because I don't even think we use it based on what I'm seeing here. Dumps entire state each write. We get the file path, path full state pickle. Okay. And then we're saying state is equal to an empty dictionary. Then we're writing an adder, passing in self, entity ID as a string, adder as a string, value is any type. If entity ID is not in self state, then self state at entity ID is equal to an empty dictionary, and then self state at entity ID at attribute. So this is a fucking dictionary within a dictionary. Okay, that's always lovely and not confusing at all to read. So we have a dictionary within a dictionary here, and then in the dictionary there is a entity ID key, and that is the value for that is a dictionary, and then you do self state at the entity ID to enter into that dictionary that value, and you are assigning, or rather just the dictionary because it's empty, you're assigning the attribute key equal to the associated value. Okay, so we have state consisting of a dictionary of entity IDs, and the entity ID is the key for an associated value, which is a dictionary that consists of an attribute name as the key and the associated value as the value. So that's a little bit recursive, but you know, it is what it is. Sure. All right. So then we have with open self file path in WB, which is write what? WB is, I'm not sure exactly what that means. Write bytes. That's writing in bytes mode because we're using pickle, right? So we're using WB as F. Okay. Then we're going over here and we're saying pickle dump self state. And this is for writing an attribute. So if it's not in the state, we create it, then we create it even further. Then we use the open file to write the state here to the file. Okay. Now, yeah, this is writing the entire state. So even if there's 30 key value pairs, yeah, even if there's 30 key value pairs here, it still will write, aka dump, that entire state dictionary. Now we have class partial state pickle, which is going to dump / write only changed attributes. Okay. And this has the base directory, which is the path partial state. Okay, then we have base directory dot make directory exist okay equals true. I don't know what that does. What does that do? It gets to this point where I am tired of not knowing what things do, and I'm ready to know what they do and to move forward as if I do. But I wish I was better at just pretending like I didn't care what I don't know, but when I don't know something, I have to know what it is before I can like go further. Which is a severe debilitating disease that I have. So user is asking about self base directory make directory exist okay equals true. This creates the directory if it doesn't exist, and if it does, it prevents errors from being raised due to the exist okay true parameter. basically self-base dir is likely a path object calling make directory, makes sure the directory is created, but it won't cause any issues if it's already there. So this is just saying if this exists, fine, but if it doesn't, you have to create it. It creates a directory if it doesn't exist, and if it does, it prevents errors from being raised due to the exist. Okay. True parameter. It's likely a path object calling make directory to make sure the directory is created, but won't cause any issues. It creates a directory, attempts to create a directory at the path specified by self.base dir. Typically, self-base dir is a path object from the path of the module. This parameter tells Python not to raise the error if the directory already exists. Without it, or if set to false, Python would raise a file exists error if the directory is already present. Okay, so this is just a path object and then it creates it. Ah, okay, so that's one of the things that you can do with path that is cool. You can create this path object, which is basically just a string, but since it's of the path class, you can call make directory on it and it will create that directory, which is kind of cool. And so if it doesn't exist, it will create this. Okay. That's nice. I don't know why we use that there, but sure. Why do we do that? I don't know. Maybe because I had asked about path and it was like, here, while we're doing this other test, I'll show you something about path that you might be curious about. Okay, so we have write adder, which is basically the same thing as the previous, except instead of having a self state, it just has the file path, which is self base directory, and joining it with the entity ID underscore. Oh, right. See, so I forgot about this. Okay, so this is what I had forgotten about. So instead of having one pickled dictionary, or one pickled object rather. Right, because I was thinking in terms of JSON, but that's not how pickle works. Pickle doesn't overwrite, like, it's not like JSON. It will... This is basically just dumping to the file, like appending. So would this overwrite if this file path already existed? I mean, it would, right? That's a question I have. I guess I'll add this into the test, my questions, and we'll say below. Would this overwrite the data at this path if it already existed? And would we need to truncate after dumping the new data? I'm assuming that it would. So this is, yeah, this is not even creating, this is not creating a new dump in a singular save file. what it's doing is it's creating new files for each attribute slash data structure. And I don't know if that's like, I don't know. I don't know what the performance. You see, there's these things you have to consider. Is what is the right way to do it? And there's a lot of different ways that you can do things, as you can see. So in this case, I forgot about this. I forgot that it had suggested this. I previously understood it, and then I like forgot it when I wasn't coding for a couple days and came back. So yeah, file path equals. So we create a new directory based off of the base directory, and we're joining it with this. We're using an F string to pass in the dynamic entity ID and then the dynamic attribute, which is pretty cool. So this would be like, let's just say player 1 would be the entity ID, and then the adder would be, would you say name? So now there's a new pickle file for player 1 name. So the question is, how slow is this? Well, we're going to find out when we run the benchmark, right? Below line. How slow is this relative to having a singular pickle file? Well, I mean, that's what this benchmark is supposed to determine. Right? I mean, that's supposed to be what it's determining, right? Yes. File path equals okay. So then we use open file path WD to write bytes as F, same thing. Below line, blah blah blah. We want to know if this would overwrite the data. I'm pretty sure it would, but we're just gonna ask that question eventually. Pickle dump the value F protocol equals pickle.highest protocol. And isn't pickle highest protocol automatically chosen? So another one is, isn't highest protocol always chosen by default? You know what I want, bro? I want a steak. I want a steak with a baked loaded potato and some mac and cheese. No. Scratch that. Asparagus. Yes. But it's got to be a loaded baked potato with sour cream, and cheese. And butter. Yes. All three. Yeah, that's what I want. That's what I want, baby. Okay, we're gonna go a little longer because I've been slacking, just straight up. Is nice protocol always chosen by default? Yes. Pickle dump value. All right. Now we have SQLite. So SQLite is the individual update, def in itself, self.db path equals game state db. That's the database file path. Then we have the connection, which I don't fully understand how this works, but apparently we connect to the database like we would to connecting to a network, you know, with a socket. So there we go. We have connected to the database through the database path. However that works exactly, I don't really understand. Then we do okay, I guess we'll ask that, right? Because we need to understand this. How does this dot connect work relative to dot connect for a socket? Same or diff? Same or diff? Give me the skinny on it, dude. Give me the skinny on it, not the fat. Give me this. What did I do? Oh shit! There he goes breaking stuff. Con equals sequel. All right. And let's be specific here, not fucking vague. Let's put below line. How does this connect? And then this is execute. I pretty much understand how this works. It creates a table if it doesn't exist. And the table is state, entity ID, adder value is a blob, and the primary key is the entity ID and the adder together, or they're both like you have to use them together, and that is the primary key, I guess. This is individual. So create table if not exists. State. The fuck is this? Okay, anyway. Create table if table not exists. State. Alright. And then what is the table? Basically just need to learn SQL, eh? Like that's one piece, whatever one. It's pretty dope. Anyway, it's a table like table does not exist state. Then we have entity ID, and then is this a field? Are these called fields? Thought they were called something like that. Primary key. So both of these together are the singular primary key, or okay. All right. So then we have right adder, which takes self entity ID string value. This is pretty much value blob. Okay. So okay. All right. So this is just creating the table, and it has these different fields: entity ID, adder, and the value is actually a blob. So the blob is gonna be like, can a, let's see here, can a Pygame object or a Python class instance be a blob? What can / can't be? All right, there we go. So these are questions that we have to answer. And I'll put also the prompt, the questions asked in test reminders.py in the pickle / SQLite benchmark. Okay, and then we have right adder. Okay, value blob equals. So this is writing to the dictionary. We pass in the entity ID, the adder, and the val, and the value blob is equal to pickle dumps. The value blob equals pickle dot dumps value. Wait, why are we using pickle here? I'm confused. What? I must be a real dumbass because why do we... I mean, we're comparing SQLite against Pickle. Why would we use Pickle? Do we have to pickle it to turn it into a blob? Why do we have to pickle this? Yeah, why do we have to? Couldn't we just add it to DB without pickling? That is the question, isn't it? So con execute, insert replace in the state and the ID, adder values. Okay, so then we do con execute insert or replace into state. So it's inserting into the table and it's passing in the entity adder value. So it's all the same table. And there we go. And then we commit it. So we're doing singular commits. And now we have SQLite batch state. So it's got transaction batching. The batch size is going to be 10. We do self db path equals game state batch database. We have our connection, our batch size, current batch equals 0. We create this table, and it's exactly the same as the previous one. Then we have the right adder, entity adder value, same as before. Then we have value blob equals pickle dump. Why do we need to do this again? Equals dumps. Okay, if self current batch is equal to 0, so then we would do self con execute in transaction. And then we have self con execute. Okay, so it's writing 10 at a time, and then once it reaches the batch size of 10, it will commit. So it's doing one commit per 10 writes, or whatever you call this. I don't know exactly what you call that. So that's another question I need to ask is write versus commit. Insert. Yeah, so I need to understand their terms. Okay, then we set current batch back to 0. Okay, that's pretty straight. I like that. Then we have the run benchmark test data. One and okay, AS. What's this? KH. It's 2C, 2CB. They got them tweaking. AS, ass. I don't know what kind of hand they got. Must have an ass hand, right? The ace of spades. Oh, the ace of spades. The king of hearts. Dumbass. The two of clubs. Idiot. Score is 100. Position X 100. Y is 200. Okay. Yeah. I mean, that's nothing. That's not enough data, dog. Whatever. Initialize handlers. Full pickle, partial pickle, SQLite individual, SQLite batch. You got a full pickle and a partial pickle, man. Somebody biting off pieces of the pickle. Num rights equals 1,000. Let's bump that up to 10,000. Well, no, we'll leave it at 1,000 first, in case it takes forever. Got results. So for name handler, handlers items, testing name. Okay, I like how they did that. That's clever shit. Let's say start time equals time. Why are we not using time it? Why do we not use time it? Like we've been through this. Isn't time it faster? Isn't time it more accurate? I thought it was, dude. I thought it was. Simulates game updates for I in range of num rights. Num rights is 1,000. Okay. Update a single attribute. Handler. Oh.
I've so longed to fight. Don't think for a moment that you're the only one that has changed.
Handler right adder player 1 score 100 plus I. What is this? For I in range of rights. Handler plus right adder player 1 score 100 plus I. Okay. Yeah, I mean, sure. Okay, and then we say if I divided by 10 is equal to 0, or I modulus 10 is equal to 0, every 10 rights update multiple attributes.
You think a barrier will work?
Handler right adder player 1 and every 10 rights update multiple attributes. What is this? Okay, it's just simulating that sometimes we would do 2 at once. But I don't know why we would never do that. Like that's, well, maybe we would. So this is batching, like very small batching. I don't really feel like we should do this. I feel like this is disingenuous. You know? Yeah, this is disingenuous. This is not really what we would want to do. This is not good for the test data. Is this good for test data? Would we actually do this? Wouldn't this mess up test results skewing against this method due to extra logic? Kinda extra, bro. This is kinda extra. I'm not even gonna lie to you. So we're gonna have to modify this if we really want to get the solid answer. You know what I mean? If we want to get some solid results here, some unbiased results, we need to. Yeah. Yeah. Well, wait, it does this for all of them. Okay. It does it for all of them. Okay, so it's not going to skew the data because it does this for all of them. But is this going to work? Hold up, let me see. So we have, where is it? Where we at? Okay, if I modulus 10 is equal to 0, so if when you divide it by 10, it's equal to 0, is that what that means, right? Yes? Explain this maths. Explain this maths to me. Alright, so yeah, then we would do right adder twice. I don't know why. So it does 2. For I in range of num rights, handler right adder. If I modulus 10 is equal to 0, handler right adder. The right adder. Okay. But why does it do this? What is the point? What does right adder do? Right adder, let's just go all the way to the top here. It will, if entity ID, okay, and then it dumps, it just does this twice. So it's just doing it twice per 4 iteration instead of once. Okay, I mean, so with pickle, this doesn't change anything. It just, it makes the ratio of iterations of the versus pickle dump actions, you know, a little more skewed towards pickle dump actions, which is like good, I guess. I mean, I would, yeah, like that's better. SQLite state, we have to connect. No, we don't. Look at the wrong thing. Okay, adder, we have blob, which I don't know if we have to blob this, so I gotta figure it out. Then we have self con execute. Okay. Self con execute. Insert replacing the state entity ID adder value values. Okay. Yeah, so this isn't going to change anything either because it commits once per, but with the batch one, this might make a difference. Well, yeah, I guess it would. I guess it would kind of, you know, it would help to, because if the iteration process is kind of slow, I mean, the for loop is constant though. So the difference of the performance of the processes, the variables are going to result in different results. Like it doesn't really matter, you know, how much we skew one way or the other as far as how many writes we're doing per iteration. Like, I guess it could improve the accuracy of the test. Like, I don't really feel like it's necessary. I feel like the difference of performance would be apparent. You know what I mean? So I understand everything so far, and this is good. The only thing that I disagree with would be, let's see. Printed. That's good. Like, they didn't make a mistake neither. They didn't make one syntactical error, dude. That's pretty impressive. Just straight up on a... Not gonna lie. Test data is apparently not used. But we do use test data. Or did we not reference it? Oh, we didn't reference it, like, in the context. We still just... It was more for reference. That's fine. Okay. Damn, they're writing stuff for reference. Like, that's... It's kind of impressive that they did that, actually. For name handler and handler items, print has a name. Let's see, what else? Seems like game and dates. So what was it? Okay, let's go to the top here and let's break down the questions I had to ask it. Speaking of breaking down, I'm gonna go take a little quick break before we do this, and then I'll come back and yeah, we'll take care of the remainder of this. So I'll be back. We're gonna take a little break. And then we'll run this benchmark. That'll probably be it after I run the benchmark. I might, I don't know. I might actually go a little past it. But this is a big step in the process. Now, after we run this benchmark, we don't have shelve being tested, but like, this is gonna give me a good idea in generally of the performance of Pickle versus SQLite, and if, like, let's see, if SQLite is faster than Pickle, I'm not gonna test shelve at all. But if Pickle is like way faster than SQLite, then yeah, I would probably test shelve, because shelve is a modified form of Pickle that allows for single value updates instead of entire file update rewriting, you know, like whatever the phrase is for that. But yeah, so we will try to take care of that. So yeah, we might test shelve after this, we might not, but either way, we're gonna understand which is the victor, Pickle versus SQLite, which took a while. What? Maybe. I mean, I'll definitely eat them at some point. All right, I'm gonna take a little break, and I'll be back. Be back. Okay, well, you know what? I think I'm gonna go to McDonald's. I'm gonna get the $5 meal because I'm feeling like a real fat ass right now, and I just want a little small Coca-Cola. I want a big ass, disgusting, fat-ridden McDouble and some greasy ass French fries. But let's do this first. Okay, we're gonna do 10 more minutes. Oh, God, I really don't feel like doing this, honestly. But let's just do it. All right. Okay, so we have dumps only change attributes, def in itself, base directory. Okay, what are we doing here? Okay, we wanted to know about. Starting at the top, we're checking off our caution comments here. So how slow is this relative to having a singular pickle file? Well, that's what this benchmark is supposed to determine, right? Yeah, true. Like, that's the point. Duh. Well, okay, so the alternative to this would be shelf. But, you know, we'll check this out, right? We'll check this out. We don't need to worry about this. I will put a note here that says remember to check shelf performance if pickle is a lot faster than SQLite, right? Okay. And we'll actually just have this as a general thing at the top right here. Okay. All right, so now we have, would this override the data of this path if it already existed? Would we need to truncate after dumping the new data? Isn't highest protocol always chosen by default? Yeah, because write creates the file if it doesn't exist, right? I think. Okay, so let's go over to chippity jip, and let's go down to the biggity bottom, baby. What is this? Okay, yeah, we don't worry about that. So that's Final Fantasy Nina. That's my favorite. All right, so let's see. It's reasoning. It's gonna figure this shit out. When using OpenFilePath WP, the file is open in binary write mode. If the file already exists, it will be truncated first, meaning the existing content will be removed and replaced with the new data, so there's no need to call truncate. As for the protocol, it's true the pickle highest protocol is the default. You don't need when using WP mode, it automatically overwrites the file if it exists. Okay. Pickle protocol by default because use protocol 3 in Python 3x unless it's specified otherwise. Highest protocol isn't automatically chosen. Wait, what? Pickle protocol uses protocol 3 unless specified otherwise. So highest protocol isn't automatically chosen. Wait, what? Started checking the docs. It turns out that when protocol equals none is passed to pickle dump, it uses the highest protocol available. However, by default, Python 3 before and above, the protocol chosen is 4 if none is specified. So the highest protocol is only actually used if specifically passed. After checking, I realized that if the protocol is set to none, pickle dump uses the highest protocol available by default, not protocol 3. For Python 3, this means we use protocol 4 since that's the default. Am I tripping or is that super confusing? Protocol is set to none. Pickle dump uses the highest protocol available by default, not protocol 3. This means we use protocol 4. I think I've got it now. Oh, so this is its reasoning. Like it's showing you how it reformed its answers, just like how I do. It like reforms its answer. Damn, that's kind of cool. I never really got to see this. Okay, so I think I've got another protocol isn't specified. The default behavior is to use the highest protocol available. Python 3 that means protocol 5. The earlier versions like Python uses 4, right? Default behavior uses the highest protocol. So the default protocol, man, ChatGPT's more all over the place than I am. Yeah, I didn't ask you all that, boy. All right. So in Python, the protocol version 4. Protocol 5 came in Python 3.8. The default protocol is usually 4. if you want to ensure the highest, wait, no, but then you Python 3.8 it's actually protocol 4. So the default protocol for Python 3x is usually 4, but for Python 3.8 it's actually protocol 4. With protocol 5 being the highest available. So if no protocol is specified, the default will be protocol 4 in Python 3.8. If no protocol is specified, the default will be protocol 4. Instead of protocol 5? Protocol 4 was introduced 3.4, protocol 5 came in 3.8. Default protocol is usually 4, unless it's specifically specified. If you want to ensure the highest protocol, using pickle highest protocol is the way to go. Already handles truncation by overriding the file. No, so you do need to use protocol equals pickle highest protocol? Hold up, bro. I'm gonna have to look more into this because pickle highest protocol. This argument is specifically just pickle don't use the highest available protocol, which may provide better performance or more efficient serialization. If you don't specify a protocol, leave it as none. Python will use the default protocol. In many recent versions of Python, the default is not necessarily the highest available. Explicitly calling pickle highest protocol ensures you're using the most current and efficient protocol that your Python version supports. Well, ain't that some shit, huh? So your code is safe and effective. Okay, gotcha. All right. Cool. Okay. Now we have with open filepath the BB as F. Below line, would this override the data at this path if it already existed? Would we need to truncate after dumping the new data? Okay, we got that. That was the one we just took care of. Then we have, how does this connect work relative to connect for a socket, same or diff? Okay, let's, yeah. Using SQLite connect self DB path, it creates a connection to a SQLite database file. This is different from the connect method for sockets, which establishes a connection to a remote server through a protocol like TCP. Both create a connection, but they're different purposes of database versus network communication. Is a function that opens or creates a connection to an SQLite database file, allowing for queries and modifications. It returns a connection object. In contrast, socket connect is used to connect both are connect functions, but the server have different purposes. Even though both are called connect, they do different things. SQLite 3 connect is a library function that creates a connection to it. SQLite database. While both methods are names, I don't want to see that. Just give me the answer though. And while both methods are named connect, they serve very different purposes and operate in different contexts. Establishes a connection to a SQLite. When you call, it opens or creates the SQLite database file at the given path and returns a connection object that you use to execute SQL commands. Okay? File-based data operations. File-based database operations, not network communication. Socket connects. Gotcha. Yeah, we are. Okay. Okay. Fair enough. What is a table? Yeah, I mean, this is pretty self-explanatory, but I mean, we'll ask anyway, right? Just to get a concrete answer. Just in case. I don't care what your reasoning. Oh, because I have reason highlighted. Dumbass. Search the web. Well, of course we would search the web. I don't know. Does it not already? Or I guess it just goes off of what it learned from searching the web already? I don't know. I guess it takes longer. For 6 seconds. Okay, in a database, a table is a structured collection of data organized into rows and columns. Think of it like as a spreadsheet. Rows, each row represents a single record or entry. Each column represents a specific attribute or field of the data. Yep, easy. For example, in a table called state, you might store data about various stages of columns like ID, name, or population. Create table if not exists. Create table instructs you like to create a new table. If not exists, choose table is created if it doesn't already exist, preventing errors. The name of the table being created. Gotcha. Okay, cool. Easy. Are these called fields? I think they are. In the context of SQL and relational database, term field and column are often used. Whoa, man, where'd you go? Field and column are often used interchangeably, though their usage can vary depending on context. Column represents a vertical set of data values in a table where each column has a specific data type and contains all values for a particular attribute across all records. For example, in a table storing information about entities, a column named entity ID would contain the identifier for each entity and typically refers to a single piece of data within a table, representing the intersection of a row and a column. For instance, the specific entity ID value for a particular record is a field. So in your create table statement, entity ID and adder are columns of the state table. Each row in this table represents a unique record, and each field is the data at the intersection of a row and a column, while field and column is more precise to refer to entity ID as columns. Okay, true. So those are columns. Okay. And then the value would actually be the field. Well, no. That's not true either. That's still a column. Dumbass. Can a pie game... okay. Yeah, we do need to know this. What can and can't be a blob? In SQLite, a blob binary large object is a data type. Whoa, that was a lot you just spit out real quick. Let's go back up to the tippity top here. In SQLite, a blob binary large object is a data type designed to store binary data exactly as it is without any modification to make it suitable for storing various types of binary data such as images, audio files, or serialized objects. To store complex Python objects, including Pygame objects or instance custom classes, you can use Python's pickle module to serialize these objects into a binary format. Once serialized, the binary data can be stored in an SQLite database as a blob. Here's how you can do it. Serialization, but do we have to serialize it? You can use Python pickle to serialize the object into a binary format. When serialized the binary data can be stored in SQLite. Well, then this like defeats the purpose, man. Like if we have to serialize the object, then why would we? We might not need to do this though, because you know we can store skeleton version of the data. We don't actually have to store the actual data like as it was. We can translate it into a skeleton format. We don't have to pickle it. Although pickling it might be faster. You know what I mean? Storing a Python object in SQLite as a blob. Serialize the object. Use pickle dumps to convert the object in binary format. Insert in SQLite to store the serialized data in a blob column. Okay. Simple Python class. Insert the serialized object. But do we have to serialize it? So you have to, yeah, you have to because it's a binary large object. So you have to pickle it. But ensure the environment used for serialization is consistent with the environment used for deserialization, as discrepancies can lead to errors, security because storing large objects as blobs can impact database performance. For a very large data, consider storing files separately and keeping references in the database. Consider storing files separately and keeping references in the database. I don't know what that means. Following this approach, you can effectively store and retrieve complex items. So they have to be serialized to be a blob. God damn it. Yes, to store complex Python objects such as Pygame object or instances of custom classes in a SQLite databases, you need to serialize them into a binary format. Serialization converts. Whoa, there you go. Giving me examples I didn't ask for. In a SQLite database, you need to serialize them into a binary format. Serialization converts these objects into a byte stream that can be stored in the database. In Python, this is commonly done using the pickle module. Well, goddamn. So, like, I'm just kind of confused, man. So, I guess really what we're comparing, because we're having a pickle an object, even when we're comparing against pickle, what we're really comparing is pickle write to a file versus pickle write to a database. You know, is that accurate? I think it is accurate. Okay, so yeah, we do have to do this. So we can't bypass the serialization. So both these together are singular primary key, or let's see what we got here. Yes, the statement primary key defines a composite primary key for the table, meaning that the combination of the entity ID and the adder columns uniquely, there he goes, uniquely identifies each row. I mean, I don't know if they think I can read the speed of light, but I can't read that fast. I'm pretty quick, but not that fast. But individually, neither entity ID nor adder may be unique across all records, but together their combination must be unique. Right, like P1 name versus P2 name, you could just, yeah, right. Cool. Okay, that's good. That's good. Yes. So now I understand. Why do we have to pickle this? Couldn't we just add it to DB? No, yeah, we have to pickle it. That has been established. Why do we have to pickle this? Yeah, same question. We just asked it twice to make sure we didn't forget it. Write versus commit versus insert. I mean, I think I pretty much get this, but I'll ask it anyway. Okay, in the context of Python SQLite 3 modules, it's important to understand the roles of inserting data, the commit method, and the concept of writing to the database. The insert purpose is to add new records to a table in the database. You execute an insert into SQL statement using a cursor object. Cursor execute insert into state entity ID adder value, and then the values are question mark, question mark, question mark, and then this. I don't know why they use that weird context. Like, why don't you just pass it directly in? Why do you have to put 3 question marks? Whatever. Executing an insert statement queues the operation within the current transaction, but doesn't immediately save it to the database file. Queues the operation within the current transaction. Okay, gotcha. And then commit operation to save all changes made during the current transaction to the database file. By calling, you finalize the transaction, making all queued changes permanent. If you don't call commit, any changes made since last commit will be lost. Okay, so right, I understand. So you can make multiple insertions without making a commit. You dig? You can do insertions without committing. Not a good look though. Not a good look. All right. Write operation purpose, a general term referring to any operation that modifies the database, such as insert, update, or delete. So writing in this, I would not say insert would constitute a write, because writing means you're writing to the actual database file. I would say that a commit would be synonymous with a write. I would say insert would be like just a local modification. These operations are executed via SQL statements to modify the in-memory representation of the database within the current transaction. Like insert, other write operations also require systems to commit to persist the data changes to the database file. So that's not actually a write. Like, so when you're writing a file, you're actually like modifying that file, which is what the commit does. Insert adds new data to the database within the current transaction. Saves all changes made during the transaction to the database file, making them permanent, and then write a broad term when it comes to the operation that alters database data. That's not a accurate description. Always ensure you call commit after performing write operation to avoid losing changes. If an error occurs, you wish to discard the changes made during the transaction. You can use connect rollback to revert to the last committed state. Okay, so you can use rollback to revert to the last committed state. For more detailed information, blah 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 blah. We can read all the documentation in SQLite 3 like some people do, but I'm not some people. Okay. As Little Louisiana said, I'm me. All right. Why do we not use time it? Isn't time it more accurate? Yeah, that's a good question. That's a good question. In Python, both time and time are used to measure the execution time code, but they serve different purposes. Function returns the current time seconds since the epoch. Counting time for 1 hour to the code block. Yeah, and then consideration can be affected by system clock adjustment. It doesn't use sufficient measure very short durations. And then specifically designed for benchmarking small code snippets, providing a more accurate measurement by accounting for various factors that can affect timing. So, conclusion, while time can be used for simple timing tasks, time module provide a more accurate and reliable method for measuring the execution time of small code snippets, especially when high precision is required. Therefore, use time it over time. Yeah. Alright, so might need to use time it instead. Is this good for test data? Would we actually do this? Wouldn't this mess up results? Yeah, no, we verified that and then explain this maths. Yeah, explain this maths to me. Because I'm not mathing, alright? I'm not mathing. Python, the expression is used to determine whether the variable I is divisible by 10 without any remainders greater than the components. Operator is a modulo. This operator returns, whoa, man. Is a modular operator returns a remainder of the division between two numbers. For example, 7 as 3 yields 1 because 7 divided by 3 is 2 with a remainder of 1. 10 modulus 2 yields 0 because 10 divided by 2 is 5 with no remainder. Comparison to 0 by comparing the result of I modulus 10 to 0, I modulus 10 is equal to 0. You're checking if I is evenly divisible by 10. If the case is true, it means I is a multiple of 10. Gotcha. Okay, easy. Easy. Modulo versus modulus. Modulo is singular. I don't know. We're not worried about that shit. This isn't. Alright, so now we can run the test. Well, that only took a year. You know, I could have got my fucking PhD in that time period, eh? Eh? Alright, well, let's run it. Let's see. Run that shit, cuz. Alright, here we go. Let's do it. Bam. There it goes. Well, that was really fast. That was insanely fast. Holy shit. Pickle is way faster, dude. Damn. Because SQL still has to pickle. Damn. 148, 150 writes per second. Yeah, so wait a second though. Either one though, it doesn't matter. Even SQLite individual, we're never gonna do that many writes per second. You know? we're never gonna need to do that many. So that means we can just do, yeah. So basically this tells us that it's sufficient. Now, uh, the reason we would use SQL is basically because it allows us to it allows us to it's more secure, right? Okay. Since Pickle is so much faster than SQLite, and we want to use a save file system using one of the two options, but I'm concerned about Pickle's um so wait, hold up, what was the damn, so a partial pickle, even creating a new pickle file, was still um way fast, was like damn near as fast as a full pickle. It was just a little bit slower, but that allows for us to like access, you know, individual attributes which we would need to do. You know what I mean? We would need to do it that way. So we wouldn't even be able to use full pickle, but partial pickle smoked SQLite batch, SQLite individual, but they're all fast enough. So the question then is, since Pickle so much faster SQLite when you use system using one of the two options, but I'm concerned about Pickle's file corruption issue. What should I do? So when choosing between Pickle's SQLite for your setting doors, it's essentially balanced performance history with data integrity. Serial Pickle offers fast serialization. J-Serial comes with penalty drawbacks, particularly. Where you at, cuz? Where you at? Particularly. Here we go. Concerning file corruption and security risks. Advantages: high performance in serializing and deserializing, straightforward implementation for quick data storage needs. Pickle files can become corrupted due to various reasons such as power outages, system crashes, or hardware failures, making them impossible to load. Okay, but if we have a bunch of different pickle files, right, that would solve the issue. If we don't just have one pickle file with everything in it, we have a bunch of different pickle files. Big data versioning changes in code base. Yeah, we're not worried about that. Reliable storage data with acid, atomicity, consistency, isolation, durability, properties, ensuring data integrity, offers better resilience against data corruption compared to Pickle. Facilitates complex queries and data management through SQL. Changes our performance, requires more setup. Yeah. Keep your concern, need for reliable, use SQL for enhanced reliability by being sold because the electric with data integrity feature make it a safe choice for persistent storage. Minimize the risk of data loss due to corruption, provides mechanisms to handle concurrent data access gracefully. Implement backup and recovery. Regardless of storage method, maintain regular backups to prevent data loss. For Pickle, implement a backup strategy to mitigate the impact of potential file corruption. Consider a hybrid approach to utilize SQLite and consider Pickle to leverage the strength of both. Store metadata and indices in SQLite while using Pickle for large non-critical data blobs. Tools that SQLite Dict offer dictionary-like interface, combining SQLite reliability with Pickle's ease of use. Wait, what is SQLite Dict? Is SQLite Dict like shelf? Feels like evaluate alternatives JSON HDF5, which might offer balancing performance and reliability. Each amount of trade-off. Also, wouldn't having in the a different pickle file for each attribute slash data point saved essentially nullify the corruption concerns of having it all in one pickle file that could be corrupted? I mean, or we could just create a second backup as well. So like if one of them got corrupted, we would just have the backup, right? So yes, SQLite, dict, and Python shell modules serve similar purposes in that they both provide persistent dictionary-like storage. However, there are key differences between the two. Backend utilizes Python's DBM data storage, stores pickled Python objects, allowing for persistence of complex data types. Performance may exhibit slower performance compared to SQLite did. Can have compatible issues across different platforms. Built on SQLite like with disk space. It offers better performance and scalability than Shell. Provides more consistent and reliable. I like the accessing through the whatchamacallit, the method that they use with individual pickled objects. I like that. That's pretty dope. Give these over to SQLite design for Shell to improve performance and reliability. So SQLite dict shelve. We do need to consider that. SQLite dict versus shelf. 325. Determine which is better, faster. And then what was the... Okay, regarding your second question about predicting file corruption concerns with storing each attribute or data point in a separate pickle file, storing each data and some pickle file can reduce the data as corruption would be estimated in the file server. This approach will reduce the child handling larger files will be 1% substantial. But we already tested it, and writing to the files is faster. It's not even like a question. Now reading, probably reading would be slower. We would have to have it that way, or we would have to use shelve. So I might just opt for the regular, well, we actually couldn't do the regular pickle thing because, so let me write this down. Oh man. Oh man. Alright, so we'll say stops here. Oh, I done forgot already what I was gonna say. Shit, I forgot. Um, okay, and then what else? Remember to check shell performance and spiggles off fast as SQLite. Can you use this spiggle? Check shell versus SQLite dict. So Pickle's way faster, but SQLite is fast enough. Consult with AI to determine that this is true, that SQLite is fast enough. Yeah. You heard the math he did. 16 times 2 is 32. You heard it. Shit. That ain't right. Oh, I'm tripping. So this was 2 hours, 2.5 hours. So that's 3.75. Damn, that's right. 3.75. Yeah, 3.75, baby. There we go. That's better. That's more like it, dude. All right, now let's do git branch. We're at the root of the project directory. Git branch, we're on secondary, which is correct. So we do git add dot to add everything. Do git commit. Yeah, double quotes. Oops, that's not right. Let's try this again. Oh shit. Oh shit. Dash m double quotes, paste it in double quotes. There we go. Oh, so we created these test files and shit. Go look at the game state DB to see what those files look like. Oh, it's not displaying text editor. Binary. Okay, so we can open anyway. Okay, so that's what it looks like in database. Let's see what this one looks like. Bunch of bullshit. Same for this one. Looks like a bunch of bullshit. Swahili, Sanskrit, Mongolian mixed together. You could never stroke the strings like that, baby. Alright, git push canasta secondary. Let's push that shit, cuz. Push that shit, cuz. Push that shit, cuz. There it goes, baby. We did it. Okay, so now we're gonna exit out of this. So we're done for the day. There we go. Big milestone. Big mega numbers, dude. We made major, extraordinary, excruciating progress. That was painful. It was miserable. It was unfortunate. Disaster. It was a series of unfortunate events, one after the other, all just for us to determine which one is better. Always, which one is better. That's what it always comes down to. Which one is better? I love a good showdown. Let's go to the end. 20. So that is indeed today's date. We did it. We're done. Oh, well, we gotta go back and rename this backup file to reflect the date of today. There we go, baby. And alright guys, so that's it. The miserable coding session. It was not coding. Well, we did some benchmarking. ChatGPT or Claude rather wrote us up that pretty dope benchmark. We did it. We benchmarked the benchmark. We marked it. We determined that Pickle is way faster. SQLite's probably fast enough. So it's just a question of which one do we want to use. We can't use the single Pickle option because we have to access it on a read. We have to access it adder by adder. I don't think we can do that in an actual Pickle file. But if we use the multiple Pickle file option, which was really fast as well, we can do that. It was just really simple. I would avoid having to do like backups, and that would pretty much avoid corruption, you know, for the most part, I think. And then we need to still test shell because then we could have a single file and access it individually, individual adders and all that. And also SQLite dict. So we'll do that next session. We're going to test those two things in that benchmark to compare how they perform. We're going to do the final little test, and then we're going to make the decision. What do I think we're going to do? Well, I think I'm probably going to just do the simplest option, which is just pickle, and that might end up being shelve. Depends on how much slower shelve is, if it's fast enough. But I do like the idea of using a database like SQLite because I did want to learn how to use database, but it seems really simple. It doesn't really seem like something that I would need to implement just to be able to say I did it. And at least for this, I don't know. We'll see. I'll make the decision. And yeah, so we'll do that next time. Have a good